Good morning, one and all. This is Dr. Diana here. Welcome to the session 6 on modern software engineering. In our previous sessions, we have been dealing with how an agile development methodology works, and specifically, we have been looking into incremental requirements gathering process and how a customer test can be conducted at a development space, and then methods for test-driven development approach and how refactoring works, why refactoring is essential in the TDD life cycle. And when we do a bit of refactoring, it's not sufficient to change just the code. We might have to change the behavior as well. So we have been looking into what incremental design of an architecture is. Now, in this session, we will look into a spike solution. A spike solution is where we perform some isolated experiments to gather more information on a bit of code, or it's more like a technical investigation process. It's a small experiment that is conducted on a bit of code to identify some problem, and it also spawns or explores over that bit of code using additional code snippets to find a solution to that problem. For example, a programmer might not know whether Java throws an exception on an arithmetic overflow condition. So when you do not know what happens at certain point of time with your code, with your produced code, you just design a simple 10-minute spike or a few more lines of code that will answer your solution. So you create a code that throws an arithmetic exception and check how your code reacts to it. This is called as a spike solution. The best way to implement a spike is usually to create a small program or a test that demonstrates the feature that you are talking about. Say, for example, my question was to identify whether Java throws an exception during an arithmetic overflow. So you create a test program or write few lines of code that create that scenario and try executing that particular piece of code. It will give you an answer or more clarity or more information on the feature in question. Spike solutions clarify technical issues by setting aside the complexity of the production code. Your production code might be highly complicated, but your question might be simple. So to find an answer to your question, all you have to do is just add few more lines of code so that it just gives you an answer. Spike solutions clarify technical issues by setting aside the complexities of production code. Sometimes you'll need to test an approach to your production code. Perhaps you want to see how a design possibility will work in practice. You might have a design in your thought process. You do not know how it actually works in practice. Or you might have to see how a persistence framework will work on your production code, or an overlay of method, how it performs or how it affects your production code. And under such scenarios, you just add that overlay over to your existing production code, and then you test it to see how it reacts or how it overcomes this particular situation. Now, spike solutions are a learning technique based on performing small and concrete experiments. So what you do is you perform a small experiment and you get a concrete response or a reply back from your code. It makes you interact with your code better and to analyze your code better so that it reveals most of its characteristics to you. Some people perform these experiments in their production code, which can work well for small experiments, but it increases the scope of possible error. As I try to add bits and pieces of code just to check my assumption, I keep on adding more lines of code which might end up in errors. So I should be very careful when I add some bits of code to a production code that's already working. And if something doesn't work as expected, is it because of your understanding of the technology, which might be wrong? Or is it due to an unseen interaction with the production code? Or is it because of the test framework itself? or it might even be because of the additional code that we added in for a spike solution. So that could be because of multiple reasons. A standalone spike eliminates this uncertainty. It gives you a clarity of why the error has happened, and it lets you know where and how to find a solution to that. Now, spike solutions are developed just then and there, and then once you receive your clarity, you start mending or refactoring your code. For stories that you cannot estimate accurately, an alternate scheduling to a spike story where you can't employ a spike story and check, you can use a high estimate. This is risky because some stories will take longer than your highest estimate and some may not be possible at all. Another option is to research problems by reading about the underlying theory, or you can try to find some code snippets in some forums online or in some books that can help you you add that code into your current development production code. This is often a good way to get started on a spike, but I would suggest the best way is to really understand what is going on in your production code and to create your own spike. Now, as we conclude on what a spike solution is, the key takeaway messages are that a spike solution is a technical investigation on a piece of code, or in other words, it's a set of lines of code that try to add a test case to some production code to clarify some feature that is in question. Thank you one and all for listening to this session. Meet you in the next. Thank you.